So yeah, without further ado, then let's welcome Vasja.
Hello, everyone, and thank you for coming. Is the sound okay? Can you hear me okay? Okay. Thanks very much for coming, and thank you to the organizers for having us here, and welcome to Fast MLOps. Just a little note before I begin. At Intelligence, we use Python for pretty much all machine learning projects that we do. However, for this talk, we're mostly going to be talking about more high-level concepts. So in case anybody is interested in deploying machine learning solutions in any other language, hopefully it will be just as relevant. So with that, let's begin. And I'd like to start by deconstructing a little bit the title, because we have some terms there that people might understand with different meanings. So first of all, fail fast. Many of you will be familiar with this phrase, may have heard it before. Fail fast is a guiding principle that prioritizes fast execution over perfect execution. So the idea is, if I spend too long trying to perfect my solution before putting it out there into the world, the situation may have changed, and by the time it's deployed, it may no longer be fully relevant or as relevant as intended. And so according to the fail fast principle, the idea is it's best to deploy the first iteration as fast as possible, and then iterate based on the feedback received. Next up, MLOps. I include here a quote from Google, where I'd like to highlight a couple of aspects from their influential article on MLOps. So first of all, MLOps, as they highlight here, refers to an ML engineering culture and practice. So we're not talking about a specific set of technologies or a specific role on machine learning projects. It's about the culture and practice. And the second aspect, so two specific processes to highlight. So automation and monitoring at all steps of the construction of a machine learning systems. So in practical terms, the term MLOps tends to be used a little bit more broadly as well to refer to a wider set of good practices when it comes to developing and deploying machine learning solutions, especially those that help to smooth the transition between the development and the operation side of things in production. So MLOps as such is an enormous field. It covers a huge amount of ground, and don't worry about not being able to read any text on this diagram. But it's a figure from a recent review that I'm happy to provide the reference later on. I think the reference just falls off the bottom of the slide. What we see here is starting off from the very beginning of the initiating the project, analysis of the business goals, and so on, going through the requirements, feature engineering, pipeline development, onto the experimentation phase, where we do what we typically associate as with the bread and butter of data science work, developing our models, validating them, and so on, and then onwards to feature stores, workflow orchestration, and automated machine learning workflow pipelines. And then all of this is tied together, you see here at the bottom, through monitoring and feedback loops. It's a vast field, and it would be presumptuous to think we can do it justice in 30 minutes, but also given our limited experience with, we don't have experience with all of this. So I selected two aspects for the talk. So we'll dwell on the experimentation part of the process, specifically around model training and validation, where I'd like to talk specifically about the concepts of traceability and reproducibility. And then after that, we'll move on to the production, and we'll talk about monitoring and feedback loops specifically, so the concepts of observability and feedback. And yeah, over there on the right is a legend just illustrating the wide variety of different roles that are involved at the various stages of the process. And then finally, last bit of the title, lessons learned. So we're not here to teach anyone a lesson. We're here very much to learn ourselves. And so whilst we have gained a little bit of experience over the past few years, having had lots of opportunities to fail and improve, we're very much here to learn. And so whatever your perspective and your experience from MLOps would be really glad to hear from you. So do please reach out after the talk. Okay, so with that, let's begin, and let's talk about traceability and reproducibility. So a lot of data scientists, machine learning engineers, and myself included, we started our data science journey through notebooks that let you intersperse the code with the results that it produces. And notebooks are a fantastic tool for lots of things, for teaching, for learning, for exploration, and prototyping, and so on. But when it comes to developing solutions for production, they can't. If your workflow is too heavily dependent on notebooks, it can lead to difficulties when it comes to the concept of traceability. And why is that? So I'm sure data scientists in the room here will appreciate that without me having to tell you. So whenever you're creating a candidate solution, you have all of these different components that go into it. And you have your input data set, you write your code for preprocessing it, you write your model training code and choose your specific set of hyperparameters for it. And a unique combination of those will produce a unique result and a unique candidate solution. What happens in the real world, all of these components go through a lot of different iterations. So for example, you may have to discard a certain part of data because a certain subset is just not suitable for the project, and you may iterate, all of those other components that go into it. And so before you know it, you have results in hand that, maybe you find it very hard to trace how exactly you got them. And let's say, for example, that, you shared your results with excited business stakeholders, and 2 weeks later they come to you, oh, we really love seeing those results, but could you rerun it just changing that one tiny little detail? And if in the meantime you iterated 10 or 15 times on your code, you might find it very hard to reproduce exactly what you did 2 weeks ago. And it can be even more difficult if the results that we're talking about were not produced by yourself, but maybe there was a colleague who worked on that project. Maybe that was a year ago, maybe they left the company since then. So given all these considerations, large amounts of work can be rendered useless in the absence of good traceability and reproducibility. So the solution to all of this, of course, involves versioning everything that you can version. So no doubt you'll be familiar with some or many of the tools highlighted here. So Git and DVC and MLflow for versioning not just code, but data sets and your models and your model results. And there was a talk earlier today, which I suppose many of you would have seen on MLflow, to introduce MLflow for experiment tracking and registering models, which was excellent. If you're not familiar with experiment tracking with an established framework, such as MLflow, I would really encourage you to give it a go, and MLflow is a great place to start. But one thing that I would like to talk about today is the concept of linking the results that you track with a tool like MLflow with the exact version of the code that was used to produce it. And specifically, the way that we do this is by using Git tags as triggers for our model training runs on a CI/CD platform. So if you run your model training on a CI/CD platform like GitHub Actions, for example, as shown here, you can configure it in such a way that the pipeline is triggered whenever you push a certain tag. So the example here shows a convolutional neural network training that gets triggered every time that I push to the repo a tag that follows this pattern, train CNN. And then for my experiment tracking code, I can extract that tag from the environment and pass it on as a tag to my experiment tracking tool, such as MLflow. And so as a consequence, when I go to my MLflow board to see all the results, we can see all the metrics resulting from a run, and higher up will be all the parameters that were tracked with the same run. For every one of those runs, we can see a Git tag that's associated with this run. Excuse me. So it seems like a part of the screen is cut off. Is there something we can do about the resolution, perhaps? Sorry, I didn't notice that earlier. think that's better. Yeah, I think that's good. It's a little bit smaller, but I think it's okay. Fantastic, thank you. So I'm not sure if you're able to read, but so on MLflow, that is the experiment tracking board where for every experiment that we run, we have a timestamp, and we'll have all the associated metrics and parameters that were used with that run. And the point I'm making here is that if we pass the git tag to MLflow, we can then get the for any experiment that we ever run in the past, we can return to the exact same version of the code that produced it. And even better, the fact of running the all our training runs on a CI/CD platform offers the possibility to just relaunch any past runs just at a click of a button, because the platforms tend to have this relaunch button at a single click. So if we return to the same example of a colleague of ours that may have left the company a year ago, I'm no longer at the mercy of having to depend on whatever documentation they left behind. But now we can just go to their MLflow board and find the best run based on the metrics, and that leads us straight via the git tag to be able to reproduce their experiments. Okay, so these concepts of traceability and reproducibility really permeate the way that we've designed our experimentation environment with which we work. And I'll talk you through how it's constructed. So everything runs in a Kubernetes cluster. And here on the top, you see we have the user tools within which individual users, mostly the data scientists, will develop their solutions in notebooks and using an IDE like VS Code. And they're connected with the data store via Minio, so connecting through to S3. And there are two, this offers a flexible environment, like a sandbox, like a playground, full flexibility for the users. But there are two intentional limitations. First of all, they have limited persistence. And secondly, they don't have write permissions back to the data store. Why is that? So it's intended such that it removes the temptation for me to, if I've just developed a model through some quick experimentation or constructed a new preprocessed data set, it prevents me from storing it under a name that I've just invented into the data store without leaving a trace that can be used by my colleagues to then track where that data set or that model came from. So whenever I have something that I consider is worth persisting, I have to go through the path that I described earlier. I have to push a tag that will launch a workflow that I defined to the code repository, and that will then trigger the CI/CD server to launch a series of jobs, the workflow for the training, and then in turn will connect with the MLflow tracking server. So the consequence of working in this way is that any produced artifacts through our experimentation can always be traced back to their origin. Okay, so for the rest of the talk, I'd like to switch gears and move to the production environment and speak specifically about the concepts of observability and feedback, and tell you a couple of stories from our own projects along the way. And I'd like to begin this section with a little thought experiment. So imagine that you're in charge of hospitals in a certain town, right? And you're tasked with improving the treatment for a certain condition. Let's call it condition X. And you have to choose, you have resources available to do so, but you have to choose from one of the 3 available hospitals. And you know about these hospitals that one of them has an 80% recovery rate for the patients treated there. Another one will have only 60% recovery rate. And for hospital C, there's no data available. Which one will you choose to allocate more resources? Most people will say the hospital with the best known recovery rate, the one with 80%, and ignore the one with no data. So it can be a real shame if it turns out that the hospital that we didn't know anything about turns out to be the best one, has fantastic doctors, fantastic facilities, but they just don't have a very good administration department and they don't submit their reports on time. What's the point of this story, right? I'm bringing it up because I think it has parallels to to machine learning solutions, in the sense that we can have a perfect machine learning solution running in production. In the absence of good observability, it can serve a little purpose, because the people who depend on it the people who need to make decisions aren't able to make informed decisions because of not being able to see those outputs. So that's on the importance of observability. And I'd like to share a little story from one of our own projects. So the visibility is not very good, but it's not, the details don't matter. We ran a project for a telecommunications company that was, so the idea of the solution that we put in production there was to automate the processing of emails coming in through to their customer service department. It was an email classification service. And so here on the dashboard, you might be able to see a timeline of the requests and the responses. So what happened on this project was we were being very careful to cover our solution with automated testing. We had a bunch of unit tests, production tests, integration tests. And it was running running stably on the side of the solution that was aimed at generating the predictions. But the part of the solution for observability, we didn't pay it so much attention. And so invariably there came an upgrade where we, with the upgrade, we broke the dashboards, we broke the observability. And intuitively thinking, maybe perhaps naively thinking, you might not pay it so much attention because if you connect via the console to observe what's happening with your solution in production, you can still see responses coming in, you can still see predictions going out, and you may be comforted, well, things are running as they should be running, and we'll just get on with fixing the dashboards in our own time. But from the point of view of the business stakeholder, from the product owner, that can be a very frustrating experience because they're left blind, and they're not able to make any informed decisions from this based on the processes they have running in production. So what we learned from this experience is that observability has to be treated as a first-class citizen. It can't be treated as an afterthought. And so the observability code requires the same amount of love and attention and testing and test coverage as the rest of your machine learning code. So far we've been talking about observing the requests and responses and so on. But another thing that's really interesting to know is whether those predictions are correct or not, right? We need to know whether the patients are not just coming into the hospital and going out of it. We need to know a week later, did they recover, did they get worse? And so I'd like to move to speaking about the concept of feedback. So in this particular case, as I mentioned, it was an email classification project. We're going from a new incoming email through various steps of preprocessing and a couple different models to produce an output, which is one of the 4 different classes. And the emails could be associated with, for example, a request to conduct some repairs, maybe related to billing or new orders or change. And the process that they had in place before we deployed our solutions to automate a part of that process went like this. So the incoming email would arrive, and it would go to operators who would manually categorize them according to which of the 4 classes it belonged to. And depending on the class, depending on the tag that they gave to the email, it would go to the correct processing queue. And then within each of those correct departments, they would open a ticket that would then go on to the correct people to address the issue that the customer brought up. And so our solution set at this point of the process. So now instead of a person looking manually and sorting all these emails, it would go to our solution. So this is deployed here in a Kubernetes cluster. And the inference workflow here would receive the email, run all that preprocessing and classification, and return the predicted email tag at the same time as then storing the prediction in the influx database for live monitoring in the chronograph dashboards. And so in order to know whether the predictions are correct or not, the idea is we need to go a step later in the process where we can extract that information. And in this case, we have to look at the tickets generated, because tickets always carry an email ID that lets us identify the email on which they were based. And so if we predicted for a certain email that it's a repair email, and then it turns out that a change ticket was opened from that same email, then that, we have to record that as a wrong prediction. and otherwise, if we predict a repair and the ticket is of type repair, then all is good, and we record it as a correct prediction. And so in parallel with our inference workflow, here we have the feedback workflow, which is receiving the tickets for feedback, and then it's storing the performance metrics in InfluxDB that go onto the dashboards, and it's storing all of those data points and the feedback, the correct labels from the tickets in a MongoDB, and that there it's available for us to run a retraining and then plug an updated retrain classifier back into the inference workflow. So one interesting thing that happened in this particular project was we thought, well, we develop our model first, and then we think about feedback later. And so once we had the inference workflow developed, we found ourselves in a situation where we didn't dare to deploy it, we didn't dare to activate our service without having the feedback in place, given all the considerations about observability. We didn't want to operate blind because, if critical processes are involved, you could be getting it wrong and not having that fast feedback to iterate on it. And so what we ended up having to do in this project was, we had our inference code just sitting there for a few weeks, making predictions, but not acting on them, whilst we were developing the feedback workflow to catch up. So what we learned from this experience is, at least in some situations, it can be very useful to think about developing your feedback workflow first. And it actually has a couple of different advantages. So, it's in line with the fast-fail approach, whereby you get your feedback as quickly as possible, and you can iterate quickly. It helps you avoid that early stage where you might be operating blind without having that feedback from the environment, from let's say the business application and so on. But also, another upshot of this approach is it lets you collect the data from the live production environment, which in many cases can be quite different from data that you might be given to develop your model in the first place. I don't know how many of you might have been given a data set by somebody saying, this is a very nicely, carefully curated, carefully selected data set. It's very clean, so use that to develop your model. Having had experience of developing models like that work great in the laboratory, but then reliably fall over on their nose as soon as you expose them to the data from the real world, it's much nicer to be able to collect all the data in the environment where the model will actually be encountering it, so that you're not developing your model based on some distributions that are completely different from the ones that it will see in production. Okay, so that brings me to conclusions. Just to wrap up, the main messages. With respect to traceability and reproducibility in the experimentation phase of MLOps, one thing that we think helps us a lot with these concepts is using CI/CD workflows to run our experiments. And we tend to trigger them by using Git tags as triggers for the CI/CD workflows. You could achieve the same with Git commits and so on, but we find Git tags just help a little bit with keeping it organized and so on. And then when it comes to observability and feedback, observability code is a first-class citizen. It can be treated as an afterthought, and it can be really helpful to at least consider deploying the feedback code before deploying the model. So we've quickly skimmed over MLOps, a couple of concrete parts of it, but that's only just scratching the surface. There's a lot more there to explore. But maybe just one concluding thought. A lot of people we speak to, clients, managers, and so on, may still have that preconception that putting a model in production effectively just means, oh, I'll develop my model in a notebook and then wrap an API around it. But in reality, there's so much more that needs to go into a mature machine learning system in production. And in fact, if you were looking for that model serving code on that diagram, you'll find it corresponds to just that one tiny little block on the edge. I hope some of that has been useful. And as I said earlier, do please reach out and get in touch. And thank you very much for your attention.
Thank you very much for your talk. Do we have any questions in the audience? Remember, you can make it the question in English, Spanish, Portuguese, I don't know. Any questions? No? Well, maybe, well, I don't know.
I'll just speak loud.
Okay.
It's a good idea to link the GitHub tags with the ML flow. Just want to ask on that, how do you train or how do you solve train a model in local, where you maybe don't have a Git commit, you don't want to run it in the Git workflow?
Yeah, that's a good question. We moved away from training in local, so we tend to train on CI/CD platform. I know that you can use MLflow for experiment tracking and just deploy the MLflow application on your local machine and run it there. So I think in terms of collaborating as a team, it helps to move it to a CI/CD platform. Individually, it may be possible. I don't know. I don't have a clear answer to that. But you could certainly use MLflow to give you that traceability aspect. And if you're working alone on a project, that's probably good enough.
We have it. Oh, here. Cool.
What is your recommendation to improve the quality of the code that the data science normally produces?
That's a good question. A few different things. One thing that we tend to do within our teams. Can you hear me okay? Yeah. So we tend to do a fair amount of code review. So we'll review each other's code, and sometimes just being in that different mindset of saying, oh, I'm in the role of reviewing somebody's code, and you may just take that little bit more attention to think about good practices than when you're coding on your own and in a hurry. So that's one mechanism. Static code analysis tools as well. Various. Automated linters, formatters, and what's the name of the Sonar Cloud? That's the one. Yes. I don't know if you're familiar with Sonar Cloud, but it's yeah. I would say a combination of these various approaches. Also insisting that. Sorry. I think maybe there's a cultural component there as well, because in certain teams, it's expected that data scientists will just, write the quickest code that will get a model trained, and maybe setting expectations within your team, if that really makes it very hard for the people who then have to productionize their code. Maybe some cultural aspects there, and a conversation about code quality can help.
Do we have another question in the audience? In the meantime, I can tell you about it now.
Hello. I think it's a good approach to externalize the data scientist team from the operation team. Like they use the MLflow tracking server, and the operational team know that there are some models there and can use them wherever they need. It's a good approach.
Thanks for the question. Good question. Maybe there are situations when it's good to have that separation. In our project, we like to keep people working a little bit more closely together. So typically, machine learning engineers and data scientists will work together through different phases of the project, and that can be helpful. Both for the data scientists to appreciate what the machine learning engineers will have to think about later on productivizing the solutions, and the other way around, maybe there are certain. I can give you an example from one of our projects to put a bit more weight on this point. So there was a model that had a specific role of the operations, maybe some filtering, some normalizations, and then some other mathematical operations. And later on, when we looked at the production code, it turned out that at some point, the order of two operations was changed. And in some cases, it doesn't matter, but in some cases, it matters a whole lot. And so if you have a strong separation between your experimentation, exploration, data science team and the people putting it in production, you maybe raise the risk of having these sort of incidents happen. So based on my experience, I would say it's usually better to have it a little bit less separated and a little bit more communicated. But maybe in some situations, a clear separation is useful. I don't know.
It's working, yes. They will be the last, so.
Y si alguien quiere preguntar en castellano también sin problema.
No, it's okay. In your day-to-day, how do you work and struggle with the difference between the data in development and in production, especially with the? I'm not talking about maybe too much about that the data is clean or not, but what the data expires, because you need newer data, no? Because it's very time series related.
Yeah.
So how do you work with the difference so you test your models and you know that it won't be an issue when you deploy?
That's a very good question, and in fact we're on a journey to be able to do that better. So currently we have too much of a separation between the laboratory data and the production data. And that loop of connecting the two, of establishing that symmetry between the experimental environment and production environment, we don't have it fully connected and fully set up and automated. So it's still a little bit manual to create new data sets for retraining based on production data. So I'm afraid I can't give you a very satisfying answer there. But if anyone has experience on this topic, it'll be really nice to have a conversation about that.
Yeah, and that was the last question, so let's thank our speaker again.
Okay, thank you very much.